In this presentation we will see the working of SR flip-flop, a very important presentation, and we will try to find out the truth table for SR flip-flop. And let me tell you, the truth table that we will deduce in this presentation is very important because it is directly used to find out the characteristic table for the SR flip-flop. You will see in the next presentation. So let's start with it. You can see that this part of this circuit is your SR latch with NAND gate that we discussed in the lecture number 119. So I will tell you, before proceeding to this presentation, it is very important that you complete the lecture number 119, because in that presentation we found out the truth table for your SR latch with NAND gate and SR latch with NOR gate, and I have already written the truth table for SR latch with NAND gate. Okay, and if you are thinking that how these values, these outputs Q and Q complement are being calculated here, then you must watch lecture number 119. We've followed the rules, we followed the instructions that we have already studied and deduced the value for the Q and Q complement depending upon that rules. So you just visit that presentation. I will give the link in the description, and first study that, a very small presentation, then move to the introduction to the SR flip-flop. So you can see that when S star R star are 0, the Q and Q complement is what? You cannot determine it. It will be a contradictory case. That's why we don't use this thing when S star and R star are 0. Similarly, when 0 1 and 1 0, we are having the values 1 0 0 1, and when S star R star both are 1, it is memory. For example, if it was 0 1 in the previous case and then I give 1 1 to S star and R star, then 1 0 is being stored again. The memory means whatever the previous value was there is being stored when S star and R star are 1. For better understanding, just watch this lecture, it will be clear to you, and if you already know, then you can proceed now. So you can see that I have modified this circuit by adding the two NAND gates, and I gave a control input. This clock is basically a control input because we don't want our input to change accidentally. We only want the inputs to change when we want. For that purpose, I need to introduce the clock here. Okay, so the first thing that you have to do is to find out what is the value of S star. So S star is the output for this NAND gate, and the two inputs are there, S and clock. So definitely it is equal to S and clock and then whole complement. If I open it, I'm having S complement or clock complement. Similarly, for R star, I'm having R and clock complement, and it will be equal to R complement or clock complement from the De Morgan's law. Now we will make the truth table for your SR flip-flop. Let me tell you what is your SR flip-flop. This whole circuit is your SR flip-flop, and the clock given to it is edge triggered. We have already seen the difference between latch and the flip-flop in the last presentation. So if I talk about this symbol, then it is represented by a box. This whole circuit is inside this box, and there are three inputs. This is S, this is R, this is clock, and this arrow type thing represents that it is edge triggered. Okay, if it is not there, it represents it is level triggered, and two outputs Q complement. So most of the times you are going to use this symbol, and this is the symbol for your SR flip-flop. So let's make the truth table. The three inputs will be there, S, clock and R. So let's make it clock, S, R. Two outputs will be there, Q complement. Okay, so let's find out the values for this truth table. If I say clock is low, which means clock is 0, then what will happen to the S star and R star? If clock is low, it means the value for S star is equal to 1. Okay, because this thing will become 1. Similarly, the value for R star is also equal to 1. So what happens when S star and R star are 1? You can see from this truth table, we are having the memory. Whatever the previous state was stored in the flip-flop or the latch, it will be there. So I can write it as memory, and you can also see one thing, that whatever be the value of S complement, R complement, it's not going to change the value for your S star and R star. So they don't care for us when the clock is low. So in this way you can see that whenever the clock is low, whatever with the input given to these two gates, it's not going to change our stored value. That's why we have introduced this clock. That's the main purpose for the introduction of the clock in our latches, or making it the controlled SR latch. Now if clock is 1, let's see what is the value for S star and R star. S star will be equal to S complement and R star will be equal to R complement, because the complement of 1 is 0. Okay, so the clock will have no effect on the S star and R star. So let's see what we are having in this case. When S is 0 and R is 0, it means S star is 1 and R star is also 1. So again the last case, and we are having the memory. Okay, and if clock is 1 again and S is 0 and R is 1, in this case S star will be what? 1, and R star will be what? R star will be 0. So for 1 and 0 we have to check from this truth table. When S is 1 and R is 0, we are having Q as 0 and Q complement as 1. So let's write it down here. Q as 0 and Q complement is 1. Now we will see for the next case when S is 1 and R is 0. So let's see what will be the value for S star and R star. In this case S star will be 0 and R star will be 1. Now let's see from this truth table, the truth table for SR latch with NAND gate. When S is 0 and R is 1, we are having Q as 1 and Q complement as 0. So Q is 1 and Q complement is 0. Now let's check for the last case. When S is 1 and R is 1 with the clock as high, I'm having S star as 0 and R star as 0. And when this happens, it is the first case and it is the not used case, it is the contradictory case. So we are having not used. So this is the truth table for your SR flip-flop, and remember it is very important because whatever you are going to study from now will be very much dependent on this truth table. So I believe that you will learn this truth table, you will understand this truth table before going to the next presentation, because in the next presentation we are going to use this truth table to find out our characteristic table, and we will find out our excitation table by using the characteristic table. So this is the first step. So do understand it and remember these things. What will be the value for your Q complement and Q, your outputs, depending upon the values of clock, S and R. So please remember this thing, it's very important. So this is all for this presentation. See you in the next one.